Hello guys, welcome to BYJU'S Exam Prep, the most comprehensive preparation app for all the competitive exams. So today I am going to discuss in brief how to do the fragmentation in IP version 4. So welcome you all to my session Coffee with Concept in Computer Networks. So fragmentation in IP version 4 and myself Murali Krishna Bukkasamudram. I am having 21 plus years of teaching experience and these are some of my credentials. You can just have a look at and I will be taking you to understand how to do the fragmentation in IP version 4 in this today's session. So join quickly and mark your presence. You can just mention, you can share this class information with your friends and also do like the session if you are really liking it and forward to your friends. Okay, so let me start the session. Before that, there is in the fragmentation of IP version 4. So how to do this fragmentation while you are passing the information from one node to another node, from one network to another network. Okay, so that's what we are supposed to do. And before that, I just wanted to give you some information regarding toppers of 2023 GATE. And this is the information on the previous 2023 GATE exam results. And our students have performed extremely well in this. And these are some of our credentials of 2023 GATE. And let us congratulate all these toppers. And I wish you all the best, all the aspirants of 2024. And there is a free scholarship test for getting up to 90% off on this national level scholarship test for GATE exam. And please do register for this. It is on 28th May, that is on coming Sunday at 12 noon. Okay, and you can get up to 90% off on all our programs. Please try to make use of this. And there is a free workshop by Abhinu Negi sir on 26th May, that is at 7:30 p.m. You can just see that. And fragmentation in IP version 4 is like this. So you see the header of IP version 4. I'll just briefly explain and concentrate more on how to do the fragmentation. Okay. So fragmentation is nothing but dividing a total datagram into different smaller chunks. How we can divide? So there is a 13-bit of fragmentation offset. It is to know how to make the fragment fit in the original datagram. So to understand the relative position of the datagram fragment. Okay. So I will show you just a fragmentation offset, the basic things. Then I will show you how do the fragmentation is happened in a particular packet. I will tell you. So this is basically 13-bit field shows the exact position of the fragment. That means in the original IP packets. It is offset of the data in the original datagram. We can say offset is nothing but relative position. It is measured in the unit of 8 bytes. It is a multiple of the 8. And the value indicates after how many bytes the fragment will start. The value of the first fragment offset is 0 always. And the second fragment depends on the length of the previous fragment. And of course, the size of each fragment in the datagram, the payload value should be multiple of 8, except the last fragment. Okay, I will show you how exactly the things are happening in fragmentation and why it is required. So basically, there will be maximum transmission units for the networks. That means some smaller networks cannot process a bigger packets. So instead, rather than dropping the packet, it will divide the bigger datagram into different chunks. And these chunks, every fragment is attached with a header and it will be forwarded in different routes. And all the fragments destined for a same destination will be received at the destination. And we need to rearrange all the fragments into single unit. So for that, we require to use this fragmentation offset. Okay, and this MTU is nothing but maximum transmissionable unit. And where when an interface is unable to process this, it will divide them into smaller chunks and forward. Like whenever a network layer sends the data to the frame, that is data link layer. Data link layer will have a header and trailer, and the data for network layer contains both payload and header. Will be a payload here. And different networks may be having different sizes of MTU, smaller units and bigger units. So there are some values of MTU is mentioned here for some networks. It depends on the physical network protocol. So table of MTU for different protocols are like this. For example, if your packet is going through hyper channels, the maximum transmissionable unit is 65,535. If it is a token ring of 16 Mbps, 17,954 for a token ring of 4 Mbps. This is MTU. MTU indicates it's a maximum transmissible unit including the header, always by default. And the most usable networks are Ethernet. For this, it is a 1500. So 1500 means 1480 bytes of payload and 20 bytes of header is required in every fragment except the last fragment, and 1480 is a multiple of 8. And coming to exact how we are going to make the fragments, I will explain here. So all of you concentrate more here. So take one data of 4000 bytes. So 4000 bytes is the single datagram. So for this 4000 bytes of data, let us assume that we are having a 20 bytes of header. Let us assume that we are having a 20 bytes of header. But when it is passed through a network whose MTU is less than 4000 bytes, okay, so definitely there is a need for dividing them into different fragments. It is like this. Okay, for example, let us assume that MTU is a 1420. MTU 1420 is nothing but including header, it is a 1420. That means data can be 1400. So 1400 is also multiple of 8, so that is not a problem. So what is this 20 header? So this 4000 bytes of payload should be divided into different chunks, and the byte IDs of 4000 bytes, byte ID 0 to byte ID 3999 in the original datagram. This is the original datagram, undivided. So the first fragment is having 1400 bytes, and also second fragment, you see, second fragment also divided into 1400 bytes. Okay, the byte number from 0 to 1399, total 1400 is in the first fragment. We can say it is a fragment 1 other than the header. And the second fragment, the number of bytes from 1400 to 2799 also 1400 bytes. This is a fragment 2. And the third fragment will be having remaining. So out of 4000, 1400 is covered in the first fragment, 1400 is covered in the second fragment, total 2800. Remaining is 1200 because the total value will be 4000 of data. Now this is numbered from 2800 to 3999. And offset value, what is this first byte ID? 0. So 0 divided by 8, offset value of the first fragment is 0. And first byte ID 1400, 1400 divided by 8, so 175 is offset value. And the first byte ID 2800 divided by 8, this is offset value. So first byte ID of the data unit in the payload divided by 8 will be the offset value of that respective fragment. Okay, that's how we are going to make the fragmentation. Okay, now if you see the exact header, so this is the original datagram, and bytes from 0 to 3999 is a payload, and this is the version, this is the header length, this is a type of service, this is a total length field. So for total length field is 4000 plus 20 is nothing but 4020 bytes, and offset value for original datagram is 0, MF value also 0, and this is the ID value. Every packet will have ID when it is leaving from the datagram network. So 14,567 is ID value. Just how the header is being filled in every fragment is shown here. So first of all, we are having the first fragment is like this. 1420 is the total length, and ID value for all the fragments of the original datagram remains same, 14,567. It is randomly assigned. For the second fragment also same ID, third fragment also same ID. But in the payload, byte IDs up to 1399 from 0 is the first fragment, up to 2799 from 1400 is the second fragment, and up to 3999 from 2800 for the third fragment. And for offset value 0 for this 175, because 0 divided by 8 is 0, and 1400 divided by 8 is 175, and this is what 2800 divided by 8, 350. These are the offset values, but ID value remains same. ID value only to collect all the chunks into one place and arrange them all the fragments into different order. That is a sequence, same sequence from the original datagram. This fragmentation offset will be used. Okay, na? So that's how we do the fragmentation in IP version 4. And making use of this lecture, you can just understand what are the entities of fragment header is the same as the original datagram, and what entities will be different from the original datagram. Header size will not be modified. If original datagram is containing 20 bytes, all the datagrams fragments will have same 20 bytes of that original datagram, and the offset values are different, and also the total length field is different because the size will vary, and there is a chance fragment may be further divided. So here this is the case. Second fragment is further divided into two more fragments. So in that case, so it is passed through a different network whose MTU is 820. So out of this 1400 of data, 800 in first fragment, 600 in second fragment. For both of them, 20 bytes are added, and ID remains same even for the fragments of the fragment also. And here, why 175? Because previous data is the first byte ID is 1400 divided by 8. Here the first byte ID is 2200 because it is covered from 1400 to 2199, total 800, and 2200 is the first byte ID of the second fragment, so that it will become 275, and it will be continued like this. MF value for all the fragments is 1 except the last fragment. That's all. So the fragmentation is done, and if you have any doubts, you can just mention in our comment box, and I hope you people have subscribed the channel. If not, please do it right now, and please do like the session if you are really liking it, and also please share with your friends. Thanks a lot. Thank you very much. See you all again.